All right, 5-4, the factor and rational root theorem. We did skip 5-3, proving identities. How do we find factors of polynomials? One way to do it is by the remainder theorem. The remainder theorem says if you divide a polynomial and let's call that polynomial p of x by x minus a can be any number that we're dividing by. Can you get that, please, Liam? Then the remainder. Good morning. I'm sorry? P of a. That's fine. Why are you afraid someone's going to mess with it? Yes, P of x. Why are you afraid someone's going to mess with it?
No, I just want to figure out your name.
Oh, okay. Well, usually I have like 18 soccer bags here, so. If you divide a polynomial P of x by x minus a, then the remainder is P of a. So example 1, it'll make more sense in just a moment, I hope. So P of x, here's our function. P of x equals x squared minus 4x plus 7. And we're going to divide it by x minus a. In this case, it's going to be x minus 5. And it's asking us what is the remainder. So we can either do long division or synthetic division. Do you have a preference? I would do synthetic. It's so much easier. But remember, we don't do x minus 5, we do just 5. Because it's in parentheses, it's a liar. So 5 goes on the outside. We look at our exponents. It goes 2, 1, none, so that's good. We don't have to add any place fillers. So we just look at the coefficients. Remember, coefficient is the number in front of the variable. So 1, -4, and 7. That's positive 7, I believe. So the 1 drops down. And now this number on the outside only multiplies. So 5 times 1 is 5. -4 plus 5 is 1. 5 times 1 is 5. This is called the remainder theorem, so I really only care about the remainder. 7 plus 5 is 12. That is my remainder. So I really only care about that right now. So our remainder is 12. Here is another way you could have solved it. What we could have done is taken P and replaced the P of x and replace the x with 5. So P of 5 equals, and wherever we have an x, we replace it with a 5. 5 squared minus 4 times 5 plus 7. 5 squared is 25. -4 times 5. Bring down the plus 7. 25 minus 20 plus 7. And what do you notice about the highlighted numbers? They're exactly the same. That is the first part of your homework. Does it matter if you do it by synthetic division or by plugging it in? Whatever makes you feel warm and fuzzy. As of right now, that's the first half of the lesson is pretty simple. As of right now. Even though I wrote it like this, I probably would not plug it in. I would probably do synthetic division. Now, be advised, do our exponents go in order? 4, 3, 2, 1. What's missing? 3. So what do we have to plug in for 3? Or for the x cubed? 0. Don't forget to do that. All right, go ahead and try that, please. Yeah, because is there an x cubed up there? No, so we have to use a placeholder. All right, about 30 seconds. All right, let's see how we did. The -2 drops down. -3 times -2 is 6. 0 plus 6 is 6. -3 times 6 is -18. 3 minus 18 is -15. -3 times -15 is 45. -15 plus 45 is 30. -3 times 30 is -90. My remainder is -81. So on your homework today, on the first half, it's going to ask you it's going to be written very similar to this, and it's going to say find it when it's -3 and like 5. So you just have to do it twice. You can either do it this way or you can do it where you plug it in. It really doesn't matter, whichever is easier for you. All right, we're halfway done. I'm sorry? Okay. Yep. Because this number on the outside only multiplies. -3 times -2 is 6. 0 plus 6 is 6. -3 times 6 is -3 times 6 is, all right, 3 minus 18 is -15. -3 times, oh, we're going all the way to that now. Oh, okay. -3 times -15 is 45. -15 plus 45 is 30. -3 times 30 is -90. 9 minus 90 is -8. Okay? We were -81. We were just looking for the remainder. That's all it wanted to know. Or if you really wanted to, you could have done -3 to the 4th times -2 plus 3 times 9 minus, or plus 45 plus 9. That would have worked too. Life is full of options. All right, rational root theorem. Rational means fraction. Ratio is a root word, so it means fraction. All right, the irrational root theorem says we take the factors of the constant. I'll explain what that is in a second. Over factors of the leading coefficient. Constant is just the number, so I'm going to write that down here. Constant is just the number. Leading, that kind of looks like cursive, sorry, I didn't mean to be. Coefficient is the number in front of largest variable. And remember, variable is largest variable's exponent. I almost forgot that. Variable is an unknown number, usually x. Exponent's the biggest exponent. Jonah, you good with me? Okay. Why do we do this? Because this gives us the possible roots. To test them, comma space, use synthetic division to see if it is a factor. And how do we find out if something's a factor? There's no what? Remainder. Good job. Like 3 is a factor at 27 because it goes in evenly. There's no remainder. All right, example 2. So 2x cubed minus 12x squared plus 22x minus 12 equals 0. So what it wants to know are what are the possible roots? What are the possible roots? The possible roots are factors of the constant. The constant is negative 12. So what are my factors of negative 12? 1 goes in it, 2 goes into it, 3 goes into it, 4 goes into it, 6 goes into it, and 12 goes into it. Those are the factors of my constant. And then factors of my leading coefficient. What's my leading coefficient? The number in front of the largest exponent. The largest exponent is 3, so it's 2. What are my factors of 2? 1 and 2. And the thing is, these factors can be positive or negative. So what is 1 divided by 1? 1. 2 divided by 1 is 2. 3, 4, 6, and 12. Those are all factors. 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, 6 divided by 1, 12 divided by 1. What is 1 divided by 2? 1/2. 2 divided by 2 is 1, so I don't need to write that. We already wrote that. 3 divided by 2 is 3/2. 4 divided by 2 is 2. We don't need to write that. It's already written. 6 divided by 2 is 3. That's already written. 12 divided by 3 is 4. That's already written. So those are all your potential roots. Those are all the places where it could possibly cross the x-axis. So, ouch. All right, so now that we know how to find our possible roots, now it wants us to solve for our actual roots. I told you, Kyla, this lesson is not my favorite lesson of the year. Because I divided 1 divided by 2. Because it's a ratio, so 1 divided by 2 is 1/2. 2 divided by 2 was 1. We already wrote that. 3 divided by 2, 4 divided by 2 is there. 6 divided by 2 is there. 12 divided by 2 is there. So those are all our potential roots. So now what it wants us to do is to actually find some roots. All right, example 3. And tomorrow's a homework day, so we have all day tomorrow to work on this if you get stuck. X cubed minus 3x plus 2, semicolon, x plus 2. Find the remaining factors. And this is just like your homework. Nope, that is a semicolon. You are correct. So yes, we are going to use synthetic division for this. So remember, it's in parentheses, so it's a liar. So I'm going to use -2. Do we have an x squared? Right, so we're going to have 1, 0, -3, and 2. Because there's not an x squared there, so we have to put a placeholder. Yes? Because if we don't, it's going to move all these over, and it's going to put it in the wrong spot and give us the wrong answer. That's why. Good question. Thank you, Johnny. All right, the 1 just drops down, and as Jonna correctly told us a few minutes ago, we multiply. -2 times 1 is -2. 0 minus 2 is -2. -2 times -2 is 4. -3 plus 4 is 1. -2 times 1 is -2. 2 minus 2 is 0. So there's no remainder, so that means that is a factor. Like on your homework, it gives you one of them that is a factor. Now, if you remember to what I told you in the past, this is your number, this is your x, this is your x squared. So I'm going to go up here. We have x squared minus 2x plus 1. It says find the remaining factors. So do you think this will factor? Are there factors of 1 that equal 2? Signs are the same, both negative. Try again. So we need factors of -2. No, hold on. Factors of, oh my gosh. I had a brain cramp there for a second. Let me get it back under control here. Sorry about that. It happens sometimes. We need factors of 1 that equal -2. Signs are the same, they're both negative. -1 equals -2. So that worked, correct? Jonah, do you see that? All right, so I can write this as x minus 1, x minus 1. Is that the best mathematical way of writing x minus 1 times x minus 1? So I can rewrite it as x minus 1 squared. You are done. That's your final answer. Those are your factors. So your factors of x cubed minus 3x plus 2 are x plus 2, and x minus 1 squared. If you were to multiply x plus 2 times x minus 1 times x minus 1, it would give you x cubed minus 3x plus 2. Crystal, you okay? We're going to do a try it, and then I was going to do the first homework problem with you. I'm going to have to turn my paper over. I'm out. Oh, hold on. Let me say it in Canadian. I'm out of space. It's a boot time, eh? I do. Well, like I said, Syracuse is literally 60 miles from Canada, so it's close. It's like Canada South. Who are you dating? A ginger? Gingers are real. All right. Let's get back onto this. Kyla, that is a semicolon again. It does look similar to a J, but it's not. It's an alien. I'm pretty sure when I write the referral for Jana, we'll see what a J looks like. Yes. An alien Canadian. Oh, okay. All right, so Johnny, once again, something's missing on this. What's missing? An x squared, so we have to put in a 0 for x squared. All right, please try this one. You are smart boys and girls and aliens. So, all right, so try it on your own. We'll go over it after I take attendance. So you're going to divide this by this. And then you're going to get a cube. You're going to get a perfect cube minus a perfect cube. So what do you think you're going to have to do when you get a perfect cube minus perfect cube? Do we have some formula or something to factor perfect cubes? It's over on the whiteboard over there. All right, so go. You're not confused. What are you doing first? All right, set it up. So for your synthetic division, do that. You did?
Yeah, I got it to where I wrote the first one down.
Hold on. I'm not ready. Slow down. All right, so what goes here? Okay.
Drop down to 1. Multiply by 2. Yeah.
So that tells me it is a factor because I don't have a remainder. So now, guess what? That's a perfect cube. That's a perfect cube. So we can do what? Difference of cubes. What? All right, Tina's here. She doesn't like Tina. Don't call her Tina. Valentina's here. Abby's here. Colin's here. Noah's here. Sakona's here. Jackson's here. Is Ty on the field trip? I thought I saw him today. Kate's here. Kyle's here. Gabby's here. Isabella's here. Cam is not here. Dominic's here. Alice is here. Alice is not here. Justin is here, sort of. Anna's here. He's here physically. Audrey's here. Yabdul has decided school's not for him. Liam, you okay today?
Yes.
Tired or just doing your own thing?
Is it like you put the book I did X minus 2 in parentheses and put the 2 on the output.
You're close. You're really close. John is here. Johnny's here. Landon's here. Elise is here. Dahlia's not here. Jonah's here. And Jolie's not here. All right. I'm ready. What? Hold on. So this is difference of cubes, right? So we do a minus b. We do a squared, opposite sign, a times b, always positive, b squared. 2 times 2 is, that's your final answer. Those are all the factors. If you were to multiply this, you would get this. Because here's x squared times x is x cubed times x is x to the 4th. There you go. That worked out. All right. That's it for our lesson. You have the rest of today and all day tomorrow to do your homework. 42. No, it's not 42.